In this lecture, we will talk about the determinant of a square matrix. We learn how to find this number, and later on, we'll learn that this number will provide us a very convenient computational criterion for determine whether a matrix is singular. Well, first, how can we denote the determinant of a matrix? So then if, for example, if you have a matrix A, 2 by 2, then the determinant of A is denoted by this symbol, right? So you have all the entries of A and the two vertical bars, one on the left and one on the right. If you see this, you know that this talks about the determinant of the matrix A, not the matrix A. And determinant, again, is a real number. So let's first talk about the minors and cofactors, the two concepts or the two terminologies that we'll use in order to find the determinant of A. Okay, so if A be an n by n matrix, and you let big Mij denote the n minus 1 by n minus 1 matrix obtained from A by deleting the row and the column containing the entry Aij. Okay, the entry Aij is the entry on the ith row and j column. So then the determinants of big Mij, so big Mij is the n minus 1 by n minus 1 matrix, and the determinant of big Mij is called the minor of the entry Aij. So we define the cofactor big Aij of little aij by taking -1 raised to I plus j multiplied by the determinant of Mij. Okay, there's a lot of definitions going on here. Well, let's look at an example. So if I have an example, I have a matrix A, let's say a 3 by 3 matrix. Okay, 1, 2, 3, 4, 0, 5, 6, 9, 9. Okay, this is a 3 by 3 matrix. I can pick an entry, let's say A11. So this is the entry A11. Okay, and from A11, I want to find M11, big M11. So big M11 is a matrix denote the 2 by 2, right? Because n minus 1 by n minus 1 is 2 by 2, such that when you delete the row and the columns that contains this entry, A11 is going to be M11. So the M11 will be 0, 5, 9, 9. Because this is the entry that I'm looking at. Delete this column. This is the leftover matrix, which means this is M11. Okay, so you have big M11, then you can find the cofactor big A11. Okay, again, it's big A11, not little a11. If you're talking about the little a11, you're talking about the entry of A, but big A11 is a cofactor of the little a11, equals to -1, 1 plus 1, and the determinant of M11. Okay, so again, if you pick any of the entry of A, you can find the minor of A, which is minor of A11, which is big M11, and you can find the cofactor of little a11. Okay. And again, the minor is a matrix, and the cofactor is going to be a real number. This is going to give you a real number, either 1 or -1. This is going to give you a real number. So the cofactor is a real number. Well, let's try another example. So if I pick this entry here, 5, okay? So this entry is on the second row and third column, so it's A23. So for A23, you can try to find the minor of A23, which is big M A23, which is equals to the leftover matrix when you delete this row and this column. So what's left over is 1, 2, 6, 9. Okay. And from here, you can find the cofactor of A23, which is equals to -1, 2 plus 3, multiplied to the determinant of M23. So you can write this is determinant of M23, or you can use the notation for the determinant. Multiply by 1, 2, 6, 9. They are the same. Okay, so we know how to find the minor of an entry and how to find the cofactor of an entry. So these terminologies, minors and cofactors, will help us find the determinant of a matrix. Again, you only want to find the determinant of a matrix when it is a square matrix. So you have the determinant of n by n matrix denoted by the DETA is a scalar associated with a matrix and is defined inductively as the determinant of A equals to A11 if n equals to 1. What is n equals to 1? That means the matrix A, it just has one singleton. Okay, so determinant of this matrix should be 2. All right. Well, then if n is greater than 1, you have at least 2 rows and 2 columns. Then the determinant of A is determined by this formula. You take the entry A11, right? Multiply to its cofactor plus the entry A12 multiplied to its cofactor, and so on and so forth, up to the last entry of the first row and multiplied by its cofactor. So that means you take the first row, find all the cofactors of all the entries on the first row, and find the sum of all these products here to find the determinant. Okay, and you already know that the cofactor A1j equals to -1 to 1 plus j, because now I is 1, multiplied by the determinant of mij. Okay. Well, let's try to use this definitions to find the determinant of a square matrix, 2 by 2 square matrix. A equals to, say, A11, A12, A21, A22. It's a square matrix. And then I can find the determinant of A by taking the first row, right? So first I have to find, for A11, I need to find M11. M11 will be just A22, because you delete the first row and the first column. So then big A11, which is the cofactor, equals to -1, 1 plus 1, times to the determinant of A2, 2. And this is a singleton, right? This is the square matrix when n equals to 1. So it's going to be itself. So it's going to be -1 raised to the 2 is just 1, so it's A2, 2. Okay. How about the second entry of the first row? A1, 2. So big M1, 2 equals to A2, 1. So then big A1, 2 equals to -1, 1 plus 2, and multiply by the determinant of A2, 1, which is -1 raised to the 3 is -1, -2, 1. All right. Now I can use the formula here to find the determinant of A. It's going to be A11 times big A11 plus A12 times big A12, which equals to A11 times A22 and plus A12 times -A21. And you can simplify this as A11 times A22 minus A12 times A21, which will give you the determinant of A, where A is a square matrix. An easier way to remember how to find the determinant of the square matrix is you're going to take A11 times A22, so cross multiplications, and minus A12 to A21. Okay. Now keep in mind, this is how you find the determinant of a square matrix. Well, now we have a 3 by 3 matrix. Let's try to find the determinant of this matrix here. You have determinant of A equals to, again, you take all the entries of the first row, right? A11 times big A11 plus A12 times big A12 plus A13 times big A13. Now we should try to find each of this cofactor. So for A11, which is 3, right? You have big A11, you have big M11 first. So delete the first row, first column to have -2, 3, 3, 2. Then you can find big A11 equals to -1, 1 plus 1, multiplied by the determinant of -2, 3, 3, 2. This is the determinant of a square 2 by 2 matrix, and we know that this determinant will want to be equals to -2 times 2, right? Minus 3 times 3. Okay, so -1 squared is 1, so you have 2, -2 times 2 minus 3 times 3, which is -4 minus 9, -13. All right. How about A12? Find big M12. So A12 is here. Big M12 is going to be 1, 3, 2, 2. Okay. And now you can find big A12 equals to -1, 1 plus 2, multiplied by the determinant of 1, 3, 2, 2. It's going to give you -1 to the 3 is -1, multiplied by the determinants is going to be 1 times 2 minus 2 times 3, which is -1, -4. You're going to get it 4. Okay. The next one is 1, 3. So big M13 equals to 1, 3 right here. Then you delete this, this is gonna be 1, 2, right here. 1, -2, 2, 3. Then you have big A, 1, 3 equals to -1, 1 plus 3, multiplied by the determinant of 1, -2, 2, 3 equals to -1 to the 4th is just 1. And the determinant of the square matrix, a 2 by 2 matrix, is going to be 1 times 3 minus 2 times -2, which give you 3, 4, 7. Okay, we found all the cofactors. Now we just need to plug the cofactors into this formula to find the determinant of A. Okay, so determinant of A equals to A11, which is 3, multiplied by -13, plus A12 is 2, multiplied by 4, plus A13 is 4, multiplied by 7, which is, you have 39 plus 8 plus 28, which is -3. Three, 2, 4. This is, you have 2, -4, 4, 2, 4, 7, -3. So -3 is the determinant of A. It turns out that you don't have to use just the first row of a matrix to find the determinant. It turns out that you can use any row I or any column J in order to find the determinant of A. For an example, given the same matrix, right? At first, I pick the first row to find the determinant. This time, I want to pick the second column to find the determinant of this matrix. Okay, so for the second columns, in order to find the determinant of A, I would take A 1, 2, right, times big A 1, 2 plus A 2, 2 times big A 2, 2 plus A 3, 2 times big A 3, 2. I'm picking the second column to find the determinant. Now the goal is I just need to find what is big A12, big A22, big A32. So for A12, I can find M12, right? A12 is here. M12 should be 1, 3, 2, 2. Then we know that big A12 equals to -1, 1 plus 2, and multiply by the determinant of this 2 by 2 matrix. That will give you -1, multiply 2, 2 minus 3, which is 2, 1 plus 2 minus 2 times 3, which is 4. Okay. A22, and you have M22. M22 right here, then the matrix big M22 is 3, 4, 2, 2. Okay, then big A22 is gonna be -1, 2 plus 2, multiply by the determinant of this matrix will give you 1, and 3 times 2 minus 2 times 4, which is going to give you -2. Okay, about A32, then M32 is going to be 32 is right here, delete this row, this column, this row, you have 3, 4, 1, 3. Then you will have A, 3, 2 equals -1. 3 plus 2 multiplied by the determinant of this matrix will give you -1. And 3 times 3 minus 1 times 4 will give you 9. Minus 4 is 5. -1 is -5. Okay. We'll combine all of this together. We can find the determinant of the matrix now using the second column as a cofactor, right? So A22 is going to be 2 times 4. A22, -2 minus plus -2 times -2, okay, and plus 3 times -5. See what we have. We have 8 plus 4 minus 15. Which is just gonna be -3. So determinant of A, again, using the second column as the cofactor, we give you the same answer. Okay. Again, you can pick any row and the columns, whatever row or columns that give you the most convenient way to compute the determinants. As long as you know how to use a formula, right? Find the correct cofactors and plug in the correct formula to find the determinants of A. But the next theorem is talking about if you have the determinants of A in transpose is the same as the determinants of A, right? And again, we know that A transpose is just the matrix where you interchange row and column from matrix A. And we know that we can use either row or column of a matrix to find the determinants. Thus, it's clear that the determinant of A transpose is the same as the determinant of A. And there's another theorem saying that the determinant of a triangular matrix equals to the products of the diagonal elements of A. Okay. Maybe it's not very clear, but if we have a triangular matrix, let's say A11, A12, A13, you have 0, A22, A23, you have 0, 0, and A33. So this is an upper triangular matrix, and you can verify the result for the lower triangular matrix. So then in order to find the determinant of A, we should pick a row or a column that helps us find the determinant quickly. I can pick the first row, right? Or I can pick the first column. And I want to pick the first column because you see the two entries of the first columns are 0. That means you only need to find the cofactor for just one entry. Okay, so picking the first column, I have the determinant of A will be A11 times big A11. All right, and by the definitions, I should keep going, right? 1, 2, 2, 1, big A 2, 1 plus A31 times big A31. Since A12 equals to 0, it doesn't matter what big A21 or big A31 are. This term just gonna be 0. I don't have to worry about this. So I just need to find big A11. So for A11, you can find M11. M11 will be A22, A23, 0, and A33. So then I can find big A11 equals to -1 raised to 1 plus 1 multiplied by the determinant of M11, which equals 2. And this is a 2 by 2 matrix. So then I can have is -1, which is just 1. And the determinant is A22 times A33, right? Minus 0 times A23, which is just 0. So what does it tell you? This is the big A11. So then I can replace this here, A11 times A22 times A33. Give you the determinant of A. As you can see that, it's just the products of all the diagonal element of A. All right, again, the determinant of a transpose matrix is the same as the determinant of itself. The determinant of a triangular matrix is the product of all the diagonal elements of the matrix. Now the next theorem tells us that if you have a square matrix, if a matrix A has a row or a column consistent entirely of 0, then the determinant of A is 0. Makes sense. If you have a 0 column or row, just pick that row or column to find the determinant. It turns out the determinant should be 0. Or if you have 2 identical rows or 2 identical columns, then the determinant of A is also equals to 0. You can try to show this, using one of the example, or you can prove by inductions to show that if you have 2 identical rows or identical columns, then a determinant of A equals 0. Or you can think of, if you have the same rows or columns, you can do one row operations. So then the next one row operation will have the next equivalent matrix will have just an entire row or columns as 0. So that's why you can determine that the determinant of that matrix should be 0. Okay, again, same rows, same columns, determinant 0, consistent of a row or columns that consistent of entire zeros, then the determinant is also 0. Well, let's do a couple of exercises here using all the theorems that we have discussed so far. Okay. A, evaluate the following determinants by inspection. So I want to use what is the determinant of A? So determinant of A is a 2 by 2 matrix, so simple. You do cross multiplications. Okay, which is 2. Simple. How about B? B, do you see anything special here? You don't have any 0 columns or row. It's not a triangular matrix, but you have a row that consists 2 zeros as entries. So you want to find the determinant of B, right? By picking the first row, and it's gonna be, so 2 is the first one. So 2 times big A11 will be just 1 times -2 minus 3 times 1. That's gonna give you -2, -3 is -5 times 2 is +5, +10. So you pick the first row to find the determinant because it contains a lot of zeros here. Well, 2 zeros is a lot in this case. All right. And again, I just want to show you that this is A11 and this is big A11. Big A11 equals to -1 to A1, 1 plus 1 multiplied by the determinant of 1, 1, 3, -2. This is how we find, this is the determinant of this here. And then we have the determinant of B. All right. Now, what is the determinant of C? Equals to, or one thing that we notice is it contains a column of R zeros. That means the determinant of C is just going to be equals to 0. All right. Well, so far, finding determinant shouldn't be too hard. Now, we have a 3 by 3 matrix. And some of the entries contain a variable x, right? Our goal is to find the determinant of this matrix, and I want to write my answer as a polynomial in terms of x. Let's try it. So determinant of A, let's see, what should I pick? I should pick a row or a column that contains at least 1 0. So let's see, the first row has 1 0, or the second row has 1 0, or the first column has 1 0. Let's pick this second row. So you have A21, and then A22, and then A23. Okay, so big M will be equals to BC1 negative x. So then big A equals to -1, 2 plus 1, multiplied by the determinant of this, which equals to -1 negative b times x minus c. Okay. Big M22 will be equals to a minus x, c, 0, negative x. So then big A22 equals to -1, 2 plus 2, multiplied by the determinants of this matrix will be a minus x, c, 0, negative x, which is gonna be a minus x times x minus c times 0, which is just gonna be, if I distribute it out, it's gonna be negative x squared plus a times x. Okay, how about A23 right here? So you're gonna delete this. You have M23 equals to a minus x, b, 0, 1. So then big A23 will be equals to -1, 2 plus 3, a minus x, b, 0, 1 equals to -1 multiplied by a minus x times 1 minus b times 0, which is just going to be negative a minus x. Okay, now combine everything together to find the determinant of A. So determinant of A using the second row is going to be 1 multiplied by this. It's going to be negative. If I distribute the negative in, I would have bx plus c. Okay. And then plus negative x multiplied by this, x squared plus ax. And then 0. Okay, well, I was a little silly that I computed big A23 because I don't need to, because this is 0. So I stop here. So then now I would have bx plus c, right? And this is gonna be plus x cubed minus ax squared. This is determinant of A. If I rearrange all the terms in the descending order, I would have x cubed minus ax squared plus bx plus c is my determinant of A. All right, so this lecture again shows you how to find the determinant of A, how to look for some special characteristic of a matrix in order to find the determinant of A in a quicker way. And keep in mind that if the determinant of a transpose is the same as the determinant of itself, the determinant of a triangular matrix is just the same as the product, right, of diagonal elements of A. So some of these theorems and properties here will help you determine a good way to find the determinant of a square matrix. Good way means fastest way.